And today we will discuss all about the evolution of calculus by Newton and Leibniz. The evolution of calculus is rooted in the independent work of Isaac Newton and Gottfried Wilhelm Leibniz. In the late 17th century, marking a significant achievements of scientific revolution, both Newton and Leibniz are credited with developing calculus, though they approach it from different perspectives and differing notations. Newton referred for his calculus as the science of fluence and fluxions. The approaches of Newton's, which is the fluxions and fluents, application of physics, and the Principia Mathematica. The first one is fluxions and fluents. Fluxions and fluents, Newton's conceived of quantities as general by continuous motion, with fluxions representing the rates of change and fluents representing of changing quantities themselves. The second is the application of physics. Newton applied his calculus to develop his laws of motion and universal gravitation. He used calculus to solve problems such as planetary motion, the shape of a rotating fluid, and the motion of the weight sliding. The last approaches of Newton is Principia Mathematica. Newton's most influential work, Philosophia Naturalis Principia Mathematica, published in 1687, laid the foundation for modern physics and engineering. In this work, he represents his laws of motion and universal gravitation, using calculus as a fundamental tool. Newton's contribution, along with those of Leibniz, laid the groundwork for the widespread use of calculus in science, economics, and
Leibniz, evolution of calculus, developed independently from Isaac Newton's, significantly shaped modern mathematics through its unique notations and approach. Leibniz's work, emerging in the late 7th century, provided tools for solving complex problems related to motions, areas, and volumes. The 5K aspect of Leibniz's development of calculus, the first one is independent discovery, the second one is notation, different triangle, inverse relationships, and publication of disseminations. Independent discovery, Leibniz developed his calculus independently of Newton, through both built upon the work of predecessors. Leibniz's approach was distinct, focusing on algebraic methods rather than the geometric focus of Newton. The second one is notations. Leibniz introduced a systematic notation that includes the integral sign and the index for differentials, which is still in use today. This notation proved more adaptable and facilitated broader advancements in mathematical disciplines.